Bismillahirrahmanirrahim. Today I will discuss the effect of 4 different factors on the yield of a chemical process. The first factor, batches of the raw material, has been represented by a column. The second, 5 different acid concentration is represented by the rows. There are 1 to 3 acid concentration there, and the rest of the data, if you go slightly up, it has been shown there. So you can see it here. Now I come to the problem. The remaining 2 factors, that are 5 different standard times represented by Latin alphabets A, B, C, D, E, and the Graeco Latin alpha, beta, gamma, delta, and epsilon. They have been shown in the main table. So how we can read this first value? So the first experiment that executed by using batch number 1, acid concentration 1, the standard time A, and the catalyst concentration alpha, we got the value equal to 26 yield. Now we will have to enter this data into the Minitab for the analysis. So for your understanding, please have a look at the batch number 1. You have 5 different observations or 5 different acid concentration. So I suggest you people to write 5 times 1, 5 times 2, 5 times 3, 4 and 5 in the Minitab first column. So just write 1 initially and you can drag it down just like Excel to the 5, then write 2 to save your time. Again, drag it down to 10. So you can see it here. I've done with the first 4 and now I'm doing it for the 5 number. So now for each of the batch we have 5 different acid concentration. So we will repeat 1, 2, 3, 4, 5 for the 5 times. So I have done this. Just copy it and paste 4 times. Trust me, it's a very shortcut method to do the data entry. Otherwise, if you do it one by one, just like you can see it here, if this is the problem and you see that we want to enter this value at the batch number 3, then acid concentration 4. So you will have to write first 3, then you will have to write 4, then A equal to 1, then gamma equal to 4. So that's a quite hectic thing and there are chances of the mistakes. Now I will write the name of factors. So the column have been given a name. Now we'll have to enter the value of these 3 cells. So it's a bit time consuming. How? So you will write here, it's 1, A is equal to 1, alpha is equal to 1 and then 26. So you will have to enter in this way that 1, then 1, then 26. Likewise you will have to enter the second one. It is for batch 1 concentration 2. So we will take this value. So it will be 2 to 16. So I will write here 2, then 16. Likewise, the third value will be 3, 19, 4, 16 and 5, 13. Now for the second row, we will enter 2, beta is equal to, B is equal to 2, gamma is equal to 3, then 18. So 2, 3, 18. 2, 3, 18. For the next one, we will have to write like this. C is equal to 3, delta 4. So 3, 4, 21. I know it's time consuming, but we will have to. Then 4, 5, 18. So 4, 5, 18. The next one will be 5, 1, 11 and 1, 2, 21. Now for the third row, it will be 3, 5, 20, 4, 1, 12. Then E is 5, 5 to 16, 1, 3, 25, 2, 4, 13. Then the second last row, 4 to 15, 5, 3, 15. It's 1, 4, 22, 2, 5, 14, 3, 1, 17. The last one will be 5, 4, 10, 1, 5, 24. Did a mistake in this value. It's 1, 3, 25, whereas it is written here, I have entered here 1, 4, 25. So please correct it. It's 1, 3, 25. Once the data has been entered, you have done a major work. Now go to stat for the analysis, then ANOVA, here GLM, journal linear model, fit journal linear model. Here select your response variable, that is yield. Now select the factors. So batch, acid, standing time, catalyst concentration, select them here. In the results, you'll have to go to expanded table, click OK. In the graph, select 4 in 1, click OK. Nothing you have to do initially, click OK. Now we have to wait for the results. So we got our results. Here you can see that each of the factor has 5 different levels. They have been kept as fixed. Then model summary, 69.26% variation in the yield has been explained by batch, acid concentration, standing times, catalyst concentration. Now if we come toward the analysis of variance, so we can see it here, the p-value associated with the standing times is only less than 0.05, that is our significance level. So it means that standing time is only found to be a significant parameter or factor or variable. Rest all of the 3 factors or variable, batch, acid concentration and catalyst concentration, they are found to be insignificant. Now if we come down, these are all of the statistic terms. So first of all, whenever you perform the experiment, I suggest you people to do the residual analysis. These residual analyses will help you in understanding the assumption of the ANOVA. So this plot number 1 and plot number 3 is depicting that our data is found to be normally distributed. This second plot is showing us that the residuals, so you can see in the center it's 0, there are positive residuals above it and negative residuals below it. So the number of positive residuals are somehow equal to the number of negative residuals. So there is equal variance or homogeneity of the variance. This fourth plot is residual versus order or observation order. It's showing that data isn't following any type of cyclic patterns, not further. There are no continuous 5 points are above this central line or below. Continuous 5 points are below this central line. So it means that data is found to be independent. There is no issue of collinearity. Now, if we have to find the regression analysis, go to stat, regression, fit regression model. Here again, enter your response variable as yield. Continuous predictor will be from batch till catalyst concentrations. Select them, click OK, and then you will get the regression analysis equation. So how you will interpret this equation? Since we have only one variable, standing time, found to be significant, so we can drop all other variables. Okay, so we can say that with the increase in the standing time by 1 unit, there will be a decrease in the yield by 2.187 units, and this will be our regression equation. Sometimes people kept the whole regression analysis equation in their research work, but those parameter variables that are found to be insignificant, there is no need of them to keep them in the model. Then the last thing, we have to plot the graphs. For the graph, you can either use this graph option or you can use the stat option as well. Go to stat, ANOVA and main effect plots. In the main effect plots, select your response variable as yield and then select all 4 factors at a time. You can do them individually as well. Click OK, and then you got these plots. These are your main effect plot. How you will interpret it? So you will interpret in this way that with respect to first batch till the 5th batch, our yield is decreasing. Now we got the maximum yield at the acid concentration. This is acid concentration number 3. Further, the standing time 1 is found to be best one for obtaining the maximum yield, and the standing time number 5 has the least yield. Now for the catalyst concentration, the catalyst concentration number 3 is found to be best one for the yield. How you will get the optimum setting? So batch number 1, acid concentration number 3, standing time number 1 and catalyst concentration number 3, they are found to be optimal conditions for obtaining the maximum yield. Still, the standing time is found to be only significant parameter, and these are over treatments that has been represented by A, B, C, D, E. So we are interested in that for the which treatment we got this difference. Go to stat, ANOVA, one way. Here you will have to select only yield because we are interested in the response, and here we are interested in the standing time because it is found to be significant. In the comparison, go select the Tukey and select here test. Please check it the tests. Click OK and then OK. So here in the result you will get the knowledge that where is the main difference exists. So we will get some kind of graph. So you can see it here. The first one has the highest mean. So it is basically the main setting that is quite different from all other four. Why? Because you can see these four levels are somehow overlapping with each other, but there is no overlapping of level number 1 with the rest of them. You can also see such thing in the box plots as well. And now if you go to the results of Tukey test, so you can see it here that whenever we compare any of other level with level of 1, they are found to be statistically significant because their p-value is less than 0.05. I tried my best to answer all of your questions. Still, if there's any question, contact me via WhatsApp or my email. I will answer your queries. Have a good day. Bye.